So let's look at this first one. Help me set up this division problem. What goes on the outside?
X plus 2.
X plus 2. And so by default, that means on the inside I would put 3x plus 8. Next thing I'm going to look for is what? The x's. How many times does x go into 3x?
3.
3 times. So this is my whole number, which means not part of a fraction, right? Which means it's what part of my transformation if it's not part of the fraction? K. So I'm going to take that, I'm going to distribute it to both of these parts up here, so I get 3x and 6. And what are we going to do with both pieces?
Flip the signs.
Flip the signs. So I'm going to make this a minus 3x and a minus 6. So my 3x's cancel, and I have what left over?
2.
Who's that?
A.
That's A. Here's my remainder. So I am ready to write this in transformation form. F of x equals, what's it going to look like? 2 over x plus 2 plus 3. Beautiful. So we got our transformation form now. Describe in words how that's different from the parent 1 over x. What does it do that the parent doesn't do? Stretch by 2. So vertical stretch. I'm running out of room for this word. Oops. There we go. Anything else other than the vertical stretch by 2? Left 2 and up 3. Okay. And then last but not least, I need the vertical and horizontal asymptotes.
X equals -2, y equals 3.
X equals -2. Is that the vertical or the horizontal? Vertical. So I'm going to label that my VA for vertical asymptote. And you said y equals what?
3.
Y equals 3. And that would be my horizontal asymptote. Nice work. That finishes off every piece of number 1. Number 2, my hint to you on this was that we needed to condense the left-hand side. What do you notice in between these two logs?
A plus sign.
A plus sign. What operation is happening between the bases when you add the exponents? Multiplication is happening. And so we are going to multiply the 4 and the x together. It's going to condense down to be just one log base 3. And we're going to multiply 4 and x. Now that I've got it down to just one log, what can I draw to help me? Triangle. What's the base of this log? 3. What's the argument? 4x. The argument goes down on the bottom because the only thing that goes up high is what? Exponent. What's the exponent? 4. So I want to rewrite this in exponential form. I start with what piece of information? The base. Remember, we're writing in exponential form. That means it's not going to be a log anymore. So we're going to start with our base, 3. And then what? Then the 4. We take our base to the power, so 3 to the 4th power. The whole goal is that we want to get that x outside of those parentheses. We want to get it on a side by itself so that we can figure out what it is. So 3 to the power of 4 equals what? 4x. Can you evaluate or simplify either one of those sides? Yeah, 3 to the power of 4. 3 to the power of 4 is what? 81. 81 equals 4x. And then what? Divide both sides by 4. What is 81 divided by 4? 20.25. Or, this is one of those fractions that does not reduce. If you wanted to leave it as 81 over 4, that is perfectly okay. All right. We are going to continue doing what we were doing yesterday. We're not learning anything new today. We're just going to take a chance to continue practicing. So our long division and our graphing. Graphing is a big part of the unit that we're on right now, and so we're going to spend a lot of time practicing that. I want to make sure that we get enough practice in, especially doing it by ourselves and then being able to check our work. So I want you guys to flip to page 201. We'll do this first one entirely together as a refresher. And then you guys will do most of the next one on your own. First thing I'm going to do before I even write down a division problem, what should I do around my corners? Plus and minus. I always want to make sure that I have that labeled up and ready to go. Then I'm going to do my long division. So I've got my division sign here. What piece do I put on the outside? X minus 5. And underneath I'm going to put what? Negative x plus 3. This one's a little bit weird, but I'm still just going to look at my x's. I have x and negative x. What should go up on top? Negative 1. So here's my whole number, my k. We're going to distribute that to the front. Negative x, or sorry, x times negative 1 gives me negative x. What about negative 1 times negative 5? Gives me 5. And then what do I do to both pieces? Yep, change both signs. We have to change this one, and we have to change the one back here. After you distribute, you change both signs every time. So what am I going to see happen? My x's cancel out. I'd be left with 2. Negative 2. So here's my remainder. Remainders are parts of fractions. So that's my a value. So let's write down our transformation. They named this one g of x, so I'm going to call this one g of x. If you write down y equals, I do not care. But I am going to try to stay consistent when we're doing example problems together. What will transformation form look like? Negative 2 over x minus 5 minus 1. All right, so let's write our asymptotes here. What is my horizontal? Y equals negative 1. So I'm going to go and sketch that one in. It shifted down 1. And what about my vertical? X equals 5. It shifted to the right 5. So I'm going to go to the right 5, and I'm going to put in a vertical asymptote. All right, I'm ready to figure out which quadrants I'm in and get this sketched. Which quads are we going to be in?
The negatives.
The negatives. So I circle my negatives. The positives are my dead zones. And how far are we going to count?
2.
2. Up, down, left and right, 2. Because that's my a value. And then we will go in 1. So up 2, in 1. Down 2, in 1. Right 2 in 1, left 2 in 1. Always go back to where they cross. Do you guys want to see me do that from the board instead of just having the dots appear? Okay. So I'm standing right where they cross. I always go back here when I start counting up, down, left, or right. So I go up, 1, 2. I can't go into the dead zone, and I can't stay on the asymptote. So I'm going to jump 1 in here, and that's where I put my dot down. Once I put a dot down, I go back to where the asymptotes cross. We went up already, so now I'm going to go down 2, 1, 2. Can't stay on the asymptote, and I can't jump into a dead zone. So I have to go this way this time and put my dot down. Again, once I put a dot down, I have to go back to where they cross. Left 2, 1, 2. Can't stay on the asymptote, can't go into a dead zone, so I have to jump up to get my dot. And then the last time, back to where they cross. Go to the right 2, 1, 2. And I have to jump into one of these quadrants, so I have to go into the open one. It's going to hug right along these asymptotes and go through the points that we drew. Just like that. All right. Yes, sir.
So you keep on jumping in 1,
Mhm.
but will we have to deal with jumping in more than 1?
Great question. No. We will always jump in 1. Always, always, always. If we were graphing this using a table, we would see like why it's always coming out to be that whole number 1. Making those tables takes a lot more time for us though, so I'm trying to keep things as basic as possible for the end of the school year. But if anybody wants to see with a table why we're always jumping in 1, I'm more than happy to show you guys. Okay? But that was a great question. Yeah, that's not getting any trickier. I want you guys to do number 4 on your own. I'm going to give you about 3 to 4 minutes to get this one done. So I want you to do number 4, just like we did with this one. what is the fully finished transformation form?
F of x equals -4 over x minus 3 and minus 1.
That is correct. Up on top, our k value, we're going to get a -1, and then we distribute that to both pieces. So I would get -x and a +3. Yep, after you distribute, you switch both signs. Always switch both signs. So my x's are going to cancel, and I get -4 here. This is my a. This is my k. So where is the horizontal asymptote then? Y equals -1. Whatever you would describe going up and down, horizontal lines are going to do that. They're going to go up and down. That's why it goes with our k. Y equals -1. What's my vertical? X equals 3. So I'm going to go and get those on the graph along with my pluses and minuses. So down 1, that's just like the last problem that we did. But this one only went to the right 3. Which quadrants will we be in? Negatives. And how far are we going to count? 4 units. So going to where they cross right here. Oh, I forgot to scribble out my positives. Let me do that real quick. Get rid of our positive quadrants because we're only going to be in the negatives, since our a value is negative. So I go to where they cross right here. 1, 2, 3, 4. Hop into the only quadrant I can. Can't stay on the asymptote, so I got to go this way. Then I go down, but I always go back to where they cross before I move in an up, down, left, or right direction. So down 1, 2, 3, 4. Hop in 1. Back to where they cross. You guys want to go left next or right next? Left sounds good. 1, 2, 3, 4. And in 1. It's going to put me right on the x-axis there. Go back to where they cross. The only direction I need to go yet is to the right. So 1, 2, 3, 4, and in 1. Right here. Hugs along those asymptotes. Has to go through the points that we plotted, though. Nice work. Up, down, left, and right, 4. And always in 1. All right. Let's flip the page. See what you guys can do with this one. And they give you about another, let's do 2.5 minutes this time. I gave you 3 minutes last time. Let's see if we can do it in 2.5. Mm-hmm. Outside. Denominator always goes on the outside. So, I know you missed it yesterday, but we talked about rewriting things like mixed numbers. Do you remember in elementary school when they would teach you like improper fractions, like 12/5, or you could write it as a mixed number. 12/5 would be the same thing as
2 and 2 big. So basically what we're doing with these when we set it up like this, we're figuring out how to write these as mixed numbers. Mhm. Did you get stuck? Oh, you're on the next one. Never mind. I was thinking, I was looking at the bottom of the page, that's what I had asked you guys to do. And then I actually looked at the number.
Technically, I'm stuck at the bottom of the page since you're not there.
There we go.
What is our transformation form? Y equals 2 over x minus 4 plus 2 is correct. Let's walk through it real quick. Make sure everybody's on the same page before we move forward. So I have x minus 4 on the outside. I have 2x minus 6 here. How many times does x go into 2x? 2 times. So here's my k, my whole number. That's why it's a plus 2 there. I take this and distribute it to both pieces, so I get 2x and negative 8. But after you distribute, every single time, no matter what those numbers are, what do you do to both of them?
Flip.
Flip both signs. So my 2x's cancel, and I end up with a positive 2 as my a value. So now I need to get my asymptotes on there. What is my horizontal? Y equals 2. And my vertical? X equals 4. So y equals 2 means a shift up 2. So up 2 right here. I'm going to put my horizontal asymptote. X equals 4. That is a shift to the right 4. So I'm going to put that on my graph. And now all I need to do is count. How far do I count? 2 units. I need to scribble out which ones. Scribble out the negatives. Hang on to the positives. So from where they cross, 1, 2, in 1. Back to where they cross, down 2, in 1. Left 2, in 1. Back to where they cross, right 2, in 1. What's the only a value that means I end up with just 2 dots? 1. Yep. We would have 1 dot in each quadrant if our a value is 1 or negative 1. So 2 dots total. So up, down, left, and right 2 because that's a. And in 1. Let's do one last graph, and we'll call it a day. very bottom one here. How do I set this up?
X minus 4 on the outside.
X minus 4 on the outside.
X minus 3 on the inside.
X minus 3 on the inside. How many times does x go into itself?
Once.
Once. So I have a 1 up on top. And so that's my a value?
Yeah.
That's my a value?
X.
That's k.
What did you say? Oh.
What goes up on top is my whole number. Whole numbers are not parts of fractions. That's how I know it's my k. I distribute that to both pieces, so I have x minus 4. Flip signs. Do not forget to flip your signs. That's going to cancel. What do I get left over? 1. So it turns out that 1 is my a value, but not for the same reason. 1 was my k value up on top because it was the whole number. A is 1 because that's what I've got left over. So what is my transformation form? T of x equals 1 over x minus 4 plus 1. So what are my asymptotes? Y equals 1 and x equals 4. So I'm going to do my pluses and minuses and get my asymptotes graphed. So y equals 1, shift up 1. If you're struggling with which one's horizontal and which one's vertical, one of the other things that you can do is look at your graph, describe the transformation in words like I've asked you to do a couple times on the bell work. If you said it goes up 1, anything that's flat like this is going to go up like this. But a vertical line, if I shift that up 1, would you notice a change? No, a vertical line I'm not going to notice if it goes up 1 because it goes on forever and ever in both directions. And x equals 4. Positive or negative quads? Positive. How many dots are we going to get? Just 2. 1 in each quad. 2 dots total. We're going to be in our positive quads. So my 2 dots end up right here and right here. When a is 1 or negative 1, it always ends up tucked back into the corner like that. Sketch it out. You guys have homework due for me tomorrow morning. You have time right now to get started on it. Bell doesn't ring to leave this class for another 13 minutes. Homework number 2, rewriting in transformation form. That is what is due tomorrow. Tomorrow we're going to keep on keeping on with the graphing, but we're going to look at a different aspect. So we've learned how to graph basic stuff, which we've been practicing for 4 days now. We've learned how if they don't give it to us in transformation form, we can use division to put it in transformation form. And tomorrow we'll look at the third and final variation that we can have. Not forever, but the only ones that we are going to look at in this class. You go on to a different class, you need to study rationals again for that class. They might dig into it deeper, but this is as deep as we're going to go with the graphing. All right?